All right, welcome back. In this one, we're going to be doing a lot of coding, starting kind of a new series, if you will, a new project, where we're going to be coding Mancala. This was historically a project and kind of a difficult one of the harder things that we did. And you'll notice there's some text files here, right? It used to read from text file in order to kind of test the game out. And we didn't learn how to do that. So last year I ended up just kind of doing it in class, and I found it like really beneficial. It's ultimately we're going to be using an integer array as an instance variable. So let's dive into this. Mancala is a type of count and capture board game. A Mancala board consists of two large pits, known as Mancalas. These guys on the ends. I've got a really good visual here. And several smaller pits. Each player owns and controls a row of smaller pits and a larger Mancala. So here says about six, half of the smaller pits. So there is a variation of this where you can kind of scale it up, include more pits for each player, right? We're not ultimately going to do that. So each player is going to have 6 pits, right? So let's just say that I am player 1. I would have these 6 pits. They belong to me. Also, this Mancala over here to the right, right? The other player, player 2, would own these 6 smaller pits in this Mancala. The game begins with each player placing an equal number of seeds in each of the smaller pits. Here in the example, right, we see 4 in each of the smaller pits. No seeds are placed in the Mancala initially, so this is an initial board state. Players take turns alternating where they remove all the seeds from one pit, from one of their smaller pits, and place seeds in each subsequent pit, including his or her Mancala, and enemy pits, but not the enemy's Mancala, in a counterclockwise fashion. This act is known as sowing, right? We're taking seeds. In this example, player 1, that's me, picked up these 4 seeds. I'm going to then sow them in subsequent order. We're going to go 1, 1, 1, 1. Okay, so I placed seeds in my smaller pits. I placed seeds in my Mancala. I placed seeds in an enemy pit. The last seed, if the last seed being sown would be distributed into the active player's Mancala, he or she would take an additional turn. So here's kind of an example of that, right? Here is the initial state. The active player, player 1, has picked up these 4 and is going to go 1, 2, 3, 4. The last seed being sown is being distributed into the active player's Mancala, player 1. He or she is going to take an additional turn. They then pick up these few seeds, right? There's 5 there. We're going to go 1, 2, 3, 4, 5. And so that's how we get those board states. So one thing I just would really like to point out is that the active player distributes seeds into any of the smaller pits, as well as their Mancala. But as it says up here, we didn't really see an example of it. Not the enemy's Mancala. So if you were sowing seeds, right, and you get all the way around, it is possible to have like 20 seeds, right, by the way. But let's just say that you like kind of wrap around, you would skip the enemy player's Mancala, right? So you would, if you were here, say you're player 1, you would skip here and then go here. Additionally, a capture occurs, and this is the hardest part about the whole game, is a capture. A capture occurs if the last seed being sown will be distributed into an enemy pit on the active player side, and there are seeds in the opposing pit on the enemy side. A capture occurs if the last seed being sown would be distributed into an empty pit on the active player side, and there are seeds in the opposing pit on the enemy side. All of the seeds in both of those smaller pits should be added to the active player's Mancala. Okay, here's a before state, and here is an after state. What the active player does, player 1, is move these seeds right here. We're going to pick up these 3, and we're going to go 1, 2, 3. Right, so we end up with that 1 there. That 9 goes to 10, and then the last seed being sown is being distributed on the active player's side, and there are seeds on the enemy player's side. What's going to happen is the seeds from both of those pits involved in the capture are going to go to the active player's Mancala. There were 5 seeds here. We ended up distributing 1 seed, the last seed being sown here. And so all 6 seeds end up in the active player's Mancala. The game is over when a player cannot make a move. So meaning his or her side of the board is empty. Okay, so here the game is over because player one doesn't have any seeds on their side, right? It is their turn in theory, and they don't have anything to sow. Okay, before we get into the coding aspect of this, I recommend you play the game. So you can just Google Mancala. And my favorite is the Cool Math Games variant, right? We see lots of different free-to-play versions, but this free, this, allow flash. I don't want to allow flash. Let's see with our math playground if we could do that without doing flash. Okay. Yeah, this is the same game anyway. Alright. Okay, so I'm going to turn it down a little bit so it doesn't blast my ears, and hopefully not yours as well. So it says it is your turn. We're player one in this scenario, right? This board is facing us. So we control these 6 bits and this Mancala here. So I'm going to do these 4. Last seed being sown went into my Mancala, so I get another turn. I'm going to do these 5. That was just like in the examples. And so now it's the computer's turn. And they did a similar thing where the last seed that they dropped went into their Mancala. So they got to go again, and they play some more seeds. Right? So this is the idea of it all. And I highly recommend that you play the game, you do some research before you actually get into coding. So this might be a good spot to pause, but I'm going to code a little bit. I'm an IntelliJ. I'm going to make a new project by going to File, New, Project. I'm going to go Next. And I'm already in my Computer Science A folder, so I'm going to create Mancala. We're not going to get super far today, just like, some instance variables, constructor, maybe a toString. I'm going to expand my project folder, right-click on the SRC, make a new Java class called Mancala. Okay, so the thing here is, with this whole game, is that we can actually use an integer array, just one integer array, to represent this. Right, this effectively, right, you just make an integer array with a length of 14. These are integers, which will represent the number of seeds. And you just designate 2 spots, one at the beginning, one about halfway, and say that those spots are the actual Mancalas out of the whole thing. So what I'm going to do is plug in some instance variables. We're going to create an integer array, which I'm going to call board. One thing that you don't necessarily have to do, but I kind of recommend, is going to create player 1 Mancala and player 2 Mancala. I'm actually going to put them on 2 different lines. Okay, these are ultimately going to be positions, indexes, as to where these things are located. Now, you don't have to create these instance variables. What it's going to end up doing is clean up our code a little bit later, so I can just refer to player 1 Mancala, player 2 Mancala, because ultimately, right, you need to basically pick this as either player 1 or player 2's Mancala, or this one, right? So here's where it gets tricky. There's a little bit of discussion, and I'm going to tell you ultimately what I think is the best, what I have just from experience, is that this is going to be player 2's Mancala, kind of obviously, but it's going to be index 0. That means this is going to be player 1's Mancala, so we're looking at 0, 1, 2, 3, 4, 5, 6, 7. Okay, so what I'm going to do is put some comments here. This is the index of player 1's Mancala. Maybe player 1 is like that. And this is going to be the index of player 2's Mancala. Why don't I just copy and paste this like an adult? These are ultimately going to be our only instance variables. Our integer array can really track our board state because each integer is going to be our seeds. We don't even really need these guys, but what we're seeing here, and the main concept that this project was even emphasizing, was an integer array, some type of primitive data type array, as an instance variable. Okay, we're going to create our constructor. And it is just going to be a no args constructor, but we want to set up the initial state of our game. Okay, so what we want to do, right, is basically fill our integer array with 4s in the smaller pits and nothing in the Mancalas. There's lots of ways to do this. We actually talked about, we did a 2-string, I think in lottery, where we talked about the differences between like preventative versus rollback, right? One thing we could do is just put 4 seeds in every slot and then set these to zeros afterwards, effectively rolling it back. The other approach is that we loop through putting 4 seeds in all the smaller pits, and when we get to the Mancalas, we skip those. Preventative, like we never put it there to begin with. These are so close, I don't even care which one you go with. So let's just let's do the rollback approach. And the reason why I'm doing that is because we can use a for each loop. That is, I'm going to just put 4 in each of these things, and then I'll set these back to 0. Okay, because this is an integer array, each individual element is an int. So if I'm using a for each loop, we're going to do for each int, which I'll call x in board. Just kidding. I can't use a for each loop. I need to actually modify the element, the index, so I'm going to need an index. So let's back this up. We're going to do a for loop. As long as I is less than board.length, I'm going to set each of them to 4. Right? With each iteration, we're going to set the current element, that is board.I, to 4. That is effectively putting 4 seeds in each spot. What I'm going to have, however, is 4 seeds in these Mancalas. So I want to roll those back. In the constructor, this is a good spot to go ahead and initialize these values. Right? I'm going to go ahead and set those, and then I'm going to immediately use them. Now, you could set them kind of anywhere in the constructor. Doesn't really matter. But player 1 Mancala, I'm going to say is this index. And I am recommending, let me double check that before we get too far. I believe I'm recommending that we set looks like in previous code I actually went a different route, right? And this is index 0. It just changes the nuances later. And what's kind of nice about the instance variables is that it doesn't really matter. You set it in the constructor and then you don't worry about it that later on. Right, so what I've done in previous, I've probably mixed it up. In some classes I did it one way, in some classes I did it the other. One moment. Oh, that was clever. Yeah, it looks like in all of them I kind of maybe went this route where this is actually index 0. So 0, 1, 2, 3, 4, 5. This is index 6. Right, so I want to basically make this that location. You could just hard code a 6. You could also do half the board length. Right, what is our board length? It's 14. I should probably initialize that. I'm trying to fill it and I haven't even initialized that. So let's do that. I'm going to take my board, and it's going to be a new integer array with a length of 14. Right? Our no args constructor represents just your standard Mancala game, and the standard Mancala board has 14 total slots on it. Okay, so we're going to loop through, set those spots to 4, and then I'm going to kind of roll back the changes. Right? Player 1 in Mancala accidentally got some seeds in it. Player 1 in Mancala, by the way, is half the board length. This is going to give me a 7 minus 1. We're back to that 6. Okay. Player 2's Mancala, thus, if this is index 0, right, this is 6, 7, 8, 9, 10, 11, 12, 13. of course, just do a hard-coded 13, considering we're doing this. I, again, like to express it in terms of the length. The idea is maybe potential scalability. This is going to be one less than the actual board length, or index 13. Okay, so here's the idea. We're going to create our board. We're going to go through, fill everything with 4 seeds. I need to roll back these positions. Player 1 Mancala, player 2 Mancala. I'm going to go ahead and set up the positions. So for the rest of the object, I don't have to say this. Everywhere where this would occur, or this would occur, or this and this, it is simply player 1 Mancala, player 2 Mancala. I'm effectively giving it a label, which is going to make it easy. Now, I set up my labels, but I need to actually fix those positions. Board at player 1 Mancala is going to be a 0, and board at player 2 Mancala is going to be a 0. Now, looking back through my code, one of the things that I saw was like, oh, that was clever, is relying on the idea of the default values here. Right, whenever we create this board, it is whenever we create this board, it is filled with zeros, right? So I go through, I fill everything with 4, but we can take a small preventative approach that would prevent us from having to do this, right? Player 2's Mancala is the last position here. So what if instead of putting 4 there, I just stop 1 early so I don't have to. I still want to set up my label, but what that means is I don't have to do this. The reason being, well, it's still a 0. It's still a 0 from the default value. I never actually placed a seed there because I end up stopping 1 early. It saves a little bit of efficiency. I don't know if it's worth losing kind of the readability, right? To me, it's kind of clear that we're doing this for both players. When you set up a situation where you're doing effectively this, it could be a little bit lost. Okay, your choice. Don't really matter. Doesn't really matter. So here's our constructor. I want to get to a position where I can kind of see what my board looks like, right? We want to create a Mancala board and see if our initial state is looking good. So I'm going to create a toString. Okay. We are going to create an empty string, and then we're going to kind of loop through. Should probably add some parentheses here. We're going to loop through and kind of build up our board as a string so that we can visually see what's going on. This is largely for testing purposes. I actually have a GUI, a graphic user interface, prepared for this particular project. So as soon as whenever we get finished, you actually have something that you can click on as opposed to, typing, that sort of thing. So here we go. Ooh, I've got some crazy stuff going on here. I'm going to loop through. Okay, so what I've done in the past is try to actually physically make it look like this board, right? What we're going to see effectively is this stuff on one line and then this stuff on another line. So I need to do this first if we want to see this line first. So I basically want to start here and loop till we get here. Okay, well this position is fortunately saved. You could do it board.length -1, but we actually saved it, right? We've labeled it. That is player 2's Mancala. So what I'm going to do is create integer I and set it to player 2 Mancala. That's going to be that position, right? Now, that's effectively a value of 13. What I want to do is loop backwards. So as long as I is going to be greater than or equal to, depending on how you end up writing this. We want this to be the last one that we do. So if we're going to use an equals to, we need to know what that position is. That position is 0, 1, 2, 3, 4, 5, 6, 7. Right? A couple of ways you could express that. Board.length divided by 2. We could do player 1 Mancala +1. You could also just say greater than player 1 Mancala, which is 6, and you don't necessarily have to add anything else to that. So this is kind of what's nice with the labels, right? We're going to start here at this position, and we're going to decrement, but we'll never actually hit player 1's Mancala. Okay, and I'll do an I minus minus on that. Okay, so this is kind of what's nice about the labels, right? We saw where if we were to actually express this using board.length or using hard-coded numbers, the hard-coded numbers are kind of messy, right? You could do this. Why do I say it's messy? Well, it doesn't scale very well for one thing. If I do decide to come in and include maybe a parameter so that our board size can change, we make a big Mancala board, then this doesn't scale with that. I gotta go and change these numbers. So that's the reason why the variables are nice, and they're definitely better than having to express this in terms of board.length. We get much cleaner looking code. So what I'm gonna do is loop through player 2 section. Okay, this is probably a good spot for a comment. Loop through player 2's board. Okay. Now, what I want to do is get that element, add it to my return string. So RTN is going to be what it currently is, along with the element at that position. If we're going to also maybe add some spacing here, more on that later, so that our numbers just don't start blurring together, right? I'll kind of show you what it looks like without that space, and you'll see why this is a good thing to do. So we're going to get ultimately all of player 2 stuff on one line, and then underneath it is going to be all of player 1 stuff. And I would like it to kind of look like this. So we've just done this portion. Why don't we actually see what we have so far? Okay, this is just going to be player 2 stuff. I'm going to right click on SRC, make a new Java class called driver. And let's plug in a main method. Create a Mancala board, or Mancala game, I should say, and see what the initial state looks like so far. I should see a 0 followed by some 4s and some spaces. And there we go. This is effectively player 2's side of the board. And what we're going to do is have player 1's side, right, a line right here, meaning player 1's Mancala is going to be underneath this 4. Okay. Yep, I need to flip back to my Mancala. So we've done player 2's side. I need to create a new line. Right. So we're going to add to RTN a new line escape sequence. And now I'm ready to loop through player 1's side of the board. In this case, I want to start here and go this way. That index is index 0. So I'm starting at index 0. Hard-coded, no way around that one. But I'm ultimately going through player 1's Mancala. So as long as I is less than or equal to player 1 Mancala, and in this case we're doing a I++. So we're going to loop through player 1's side of the board. With each iteration, I'm going to grab the current element, add that to my board. And this should be on a new line because we put a new line in between our 2 loops. Okay. And there we go. So our initial state looks pretty good. We got a 2-string going, and we're going to pause right there. I'll see you in the next one.